All right, everyone, thank you for joining us on this fine Wednesday afternoon. Looks like we've got 27 people, and Adam has just turned on the recording. Maybe give folks one more minute just to see if anybody else joins. Adam, you want to start up the slides?
Yep.
Great. Hello, Jake. See you on as well.
You're up.
All right, well, I think we'll go ahead and get started just a couple minutes after the hour. So for those of you who were with us yesterday, this will be similar but focused on TransModeler and the material and the guidelines related to TransModeler. But this is, the KYTC Microsimulation Guidelines Training Session number 3, TransModeler specific training. So just say welcome. And actually, Scott, I think you had your video on. I don't know if you wanted to say anything, or Jay, if you wanted to say anything to this group.
I'm pausing to give Jay a chance to talk first. Seeing that she's a little bashful, I'm excited at the number of participants we have. We have nearly as many participants here for the TransModeler session as we did yesterday's VSim. That's exciting. It demonstrates that TransModeler is out there. We just don't see a lot of studies that utilize it. HDR has worked hard for 3 years. It would be remiss if I didn't mention Lindsay Walker, who was one of the first to be involved in this process, along with Rob Fraser. Today's session is focused on just TransModeler, just like the documentation has been transcribed, if you will, so that you don't have to flip back and forth or read through other material that you may not necessarily have an interest in at the time. So without further ado, I present to you HDR's coming out party for our microsimulation guidance. Take it.
All right, thank you, Scott. All right, well, we are going to do things today similar to, but just a little different than yesterday. So everyone will have an opportunity to introduce themselves, type in name and email. So we've got a record of folks here in a minute using Mentimeter, and we'll give you the code here in just a moment. You see the other two folks that'll be involved here. And I'll have them introduce themselves here, and when we get to a few screens down. So let's go ahead and go on to the next slide there, safety moment. So I'm just make this real quick. I had a good engineer friend. It was a rainy day, and he forgot that he was getting older, but more importantly, he just did not properly take into account the fact that when you are out walking, granite gets slippery. And so I kid you not, we're having, it's work, right? We're all supposed to be, we're usually pretty safe at work, but he decided to jump off of a granite slab onto the sidewalk. He slipped, he broke his leg. Next thing you know, I'm taking him to the hospital in his rental car. So just always be aware of your surroundings. So, but I think today's looking pretty sunny, so not an issue today. But that's just my real life safety moment. Is just don't run and slide on wet granite. So next slide. housekeeping, again, if you were with us yesterday, these are the same general ideas. Open discussion, so please use the chat, raise hand feature, but also be willing, be great if folks were willing to unmute themselves and speak. We have had some good discussion last 2 sessions, and ask questions, please. This is a great opportunity to talk through some things. And I think a few of the things that were brought up are really ongoing discussion items. This is because a lot of smart folks on this list. I'm looking who's here, and so if we don't have an answer to something, maybe someone else does, and that actually came up a couple times. So I'm glad to have those. We're glad to have those conversations. When you're not speaking, put yourself on mute, and then camera. You can just keep that off for bandwidth purposes. But if you do want to talk, you're welcome to turn on your camera. It is being recorded, and we want Q&A throughout, but we'll make time for it at the end as well. And so that's the housekeeping slide. Yeah. Next thing is Mentimeter. So we do ask, and even if you were here yesterday, please go ahead and log in to menti.com. Please open up another browser window. You can use your cell phone if you are on a laptop and you don't want to cover the screen. You can use your cell phone. Just go to menti.com and type in the code that is on the screen there, 11513129. Type in that code. It's on the join. There's a Menti join. Just type in the code, and it'll take you right to the next question. And folks are already doing it and typing in their information, and so we'll use that periodically throughout. So the first one is introduce yourself, name, firm, and email. We didn't put any no favorite food, color, or animal today. Just kind of keeping it simple.
I was going to go with, is a hot dog a sandwich, but I thought that was going to be too much pressure.
So please let us know who you are so we can have a record and make sure that we get information out to folks.
I was all set to give you my favorite pastime.
Welcome to share it anyway, Scott. Go ahead, well, folks are typing in. We have 39 folks. So I'm going to echo what Scott said. Thank you very much for everyone taking time and joining today. And we do have 2 hours blocked out. We will try to we end early. We hopefully won't go that long, but we'll use as much of it as is needed. So all right, I think we've got most everyone, 32. So we can thank you again for doing that. And let's press on to the next.
And I think we mentioned this in previous sessions, but the kind of getting all the attendees' email and information will help kind of notify you once we kind of push all this information on the web. So we're very close to that point with the guidance document, with the kind of the seed files and the reference materials, and then these training sessions. Both the materials, I guess, and the video presentation. We're going to try to all have that accessible to everybody. So if we kind of get your email here, then we can make sure that you're on the list of people to be notified. So you're not just randomly stumbling on it. So
I thought I might share with this group also a question that came up after yesterday's presentation. Someone was asking if this training was mandatory for pre-qualifications. It isn't not at this point. I think we could, at this point, this is a kind of a grand opening of sorts. We wanted to get the word out and get feedback, hopefully for everyone as to what they like about it, what they would love to see as maybe the next version. Areas to expand upon, but as we move more formally into a practice, this is not a requirement for pre-qualification.
Thank you for clarifying that, Scott. Yeah, good for everyone to know. So here's the agenda, and Adam, I'm going to ask you because I don't have this presentation open on my other screen. Do we have another slide for everyone involved? Is that
Yeah, so it is a bit of an odd order. I realized in the last two presentations, but I thought I'd keep it consistent
all right?
to
So,
talk about what we're going to talk about and then kind of who's going to talk about it.
okay, all right.
But yeah,
So
that is right. It's the same. Yeah.
all right. So yeah, so introduction is kind of what we're doing right now. We're going to talk a little bit about the benefits of TransModeler, and then different versions of TransModeler, and then do some kind of quick overview, software overview. Again, Adam will be quick to say this is not a session on how to set up a model. Do all work you need to do if you're doing a TransModeler model. That's not what this is, but it assumes some level of kind of understanding to do some of it. But I mean, you can, but you'll get something out of it even if you don't. So but that isn't the purpose of the class. Is to teach how to do TransModeler. But more to go into what the guidelines have to say and best practices, which is item number 5, and then the parameters, how you might code it, and then some common issues, and then documenting things. So it is kind of at a little bit of a higher level, and that's the general agenda. So finish up with resources and Q&A, and the folks that are involved, I believe, is the next.
This is just
yeah.
going to specify the end. I mean, if you've made it here, you're probably aware that there were 2 other sessions, but
yes, this is the final session, and all the folks that have been involved, and so thanks to Scott, Jay, Connor, David, Noah, review and feedback, and working throughout the development of these the guidelines. So thank you to them, and then Adam and myself and Jacob are on this discussion. Steve was on yesterday. So, all right, Adam, we're back to Mentimeter.
Yeah. So these are similar questions, and it's a similar format to yesterday, but I felt like it was helpful. These are not the most groundbreaking of questions, but it does kind of help understand kind of the level of expertise of everybody. This is no surprise that everyone's heard of TransModeler on this question, so I can kind of go ahead and
responded to
jump to the next one.
Yeah, it's gone to the next one.
Yeah, so maybe a little bit into the weeds a bit more. So you'll start to see a trend of the number of people might decrease as to who's opened it and who hasn't. So from 100 to kind of 70-30, and then the third question of how many of you have actually developed models in TransModeler. Okay, similar. I mean, about 50-50. So, yeah, it's good to, again, just to kind of understand where everyone is in the audience. We're not, obviously it's anonymous. We're not trying to pick on anybody or know exactly what you know, but it just helps kind of set a baseline of how to proceed through the presentation. So, oops. Sorry. I was getting ahead of myself on the wrong slideshow. So, throughout the presentation, I'll probably just pass back and forth between me and Rob and Jake on the phone here, and so both of you feel free to jump in or add in, and same with anybody else listening in. If you have something to add or a question, again, using the chat or just kind of jumping in and clearing space is totally fine. So just kind of looking at a high level, what is TransModeler? Seems like everyone is fairly familiar here on the call, but it's the caliper kind of microscopic, mesoscopic analysis tool. So Caliper also makes TransCAD and Maptitude and some other products, but this is kind of their microscopic tool. There are really two versions that at least I've really seen used. I guess there's some older versions, but at this stage it's really version 5 or version 6. And there are also SE versions associated with each of those. And then kind of some other just high level things. It's developed, it's a software developed in the US. I know that is a point of contention. I'm not trying to compare the two, Vissim and TransModeler, but it does come up often with Vissim that it isn't a software that was necessarily developed here, and so a lot of the defaults might not be reflective of US behavior. So it's just worth mentioning, and similar to Vissim, I guess, in that way, it's microsimulation, and it can kind of analyze any configuration that you have. So again, not really comparing them, but just pointing out the obvious things in the room, I guess. Another kind of high point or key feature, it's I think also listed in the benefits here, is the integration with TransCAD. And so TransCAD is used for travel demand modeling. A lot of areas, but it is used in Kentucky. The statewide models and some MPO models are using TransCAD. So the ability to kind of communicate general network settings or import things in from TransCAD to start your network can be useful. It's not a perfect clean thing to do, but it can kind of help you get started. And so thinking about just the benefits of TransModeler, which kind of
Adam, before you do the benefits, I'm just going to mention, Tom put into the chat that version 6.1 is to be released by the end of the year. So just that version.
Okay.
May I throw in one thing? Just to,
yeah, sure.
The new features will include being able to simulate CAVs, connected and autonomous vehicles as their own vehicle fleet. So we've actually used that for a couple of simulation studies with Ohio DOT. So there'll be a number of new features, but CAV simulation and automating that as a vehicle type within the default settings will be one of the features.
Okay, cool. I actually think I might be pointing that out in a few slides, but yeah, you jumped the gun on me. So the benefits, kind of, again, high level, there are probably many more you could list, but if you're new to using the software or you're not sure why you may or may not use it, just kind of something I've been mentioning in the other sections, the ability to analyze kind of different operational conditions. And Tom actually pointed out in the first session that HCS is going to be updated to do the same kind of thing in a deterministic way. But really, as we have things now, you're really going to want to use a microsimulation tool to look at scenarios where you have interrupted and uninterrupted flow together. They can look at all those kind of configurations. You're not really able to do that in other tools as one model. So the other thing, the TransModeler, the first I ever kind of heard of using it was to do dynamic traffic assignment. So it's kind of readily integrated into the way that it's doing vehicle routing and the assumptions that the model makes. And so it's a feature that's readily available. And then also the look at the default values. When we did the parameter analysis, there were a lot of things in TransModeler that seemed to line up with kind of the data we had for Kentucky. So, it's likely to assume that the starting point is maybe closer to where you're headed. And again, the compatibility with TransCAD. And then if you are a GIS user, which is actually kind of how I would have first used TransModeler, was coming from Maptitude, another caliper product, or if you're familiar with TransCAD, the user interface is kind of in that same kind of layer tables and layers format that interact with each other. And so if you're familiar with that type of interface, then this might come kind of easily to you. So again, there are other things to mention, but just kind of
And
something
Adam,
I thought.
I was going to
Yeah,
jump
go
in
ahead.
quick. On that last bullet, that's kind of what we're showing on the left-hand side of this slide,
Oh, right.
is the aspect where you can almost bring in more or less a shape file or any kind of geo-reference data into your model to maybe improve it from a visual standpoint. So this was a DDI in Northeast Ohio that we did, where some users or some people that lived around here were concerned about how they would cross the DDI. So we made sure to show the sidewalk network from the final design into our simulation model. So we actually have a video of this. This is just a still that I kind of pulled from this, but when we were looking at those visualizations, having that ability with that GIS interface, setting up layers and kind of showing different things that you can't necessarily put in TransModeler, but you can kind of show them from a layer standpoint on top of the model can definitely add some value to this platform.
Yeah, so just in this example, right, the kind of red sidewalk lines, the white crosswalks, the blue curb lines, those are all imported features from the final design. And
Yep.
then the gray roadway network is the TransModeler piece. So the two things are kind of blended together in this example.
Correct. And yeah, it can definitely help draw your alternatives to the correct specifications as well. So you can actually import like a KMZ or any sort of kind of georeference file and kind of draw on top of it when you're developing these alternatives in TransModeler that can help set intersections in the right area, get your curvature correct on specific roadways, etc.
Okay, so I'm going to kind of continue on here. The compatibility with TransCAD is something I've mentioned a few times. Jake, do you want to kind of talk a little bit more about maybe this specific example?
Yeah, so I think depending on the size of the model that anyone maybe on this call will eventually develop, there can be a lot of efficiencies when being accustomed to working with TransCAD as well. So since a lot of the layers are the same, more or less, kind of the base layers, links and nodes from TransCAD are also in TransModeler. You can use those and attributes that are already maybe coded into the TransCAD network to effectively convert a TransCAD subarea or even a full MPO model or statewide model into TransModeler, and then you would add the more finer grain detail, the turn lanes, the signals, etc. It's not, you don't just convert it directly and you can hit play. There's obviously some work after the fact, but there's kind of a good balance of if your model's small enough, you can just kind of develop it from scratch. But if it's large enough, sometimes there's some benefits to using TransCAD, and then you have that one-to-one kind of nodes and links comparison that you can go back and forth with TransCAD if you're growing your OD table for demand, etc. So this is just an example of that it would take a while to draw all this by hand. In the Des Moines, the capital of Iowa, the interstate system there, but we kind of use some efficiencies that TransModeler has built in to bring in the TransCAD network and use that to our advantage to kind of develop this interstate model.
Yeah, and I guess we pointed it out, but the key in Kentucky, I guess, is it as it applies is the TransCAD is already being used, and so potential for doing that is there and is relevant. So, talking a little bit about the versions, I just kind of wanted to point out maybe some differences between 5 and 6 and then SE. So they really seem like 6 is an upgrade of 5. It isn't a complete revamp or anything like that, but there's some analysis enhancements. I know that we've talked to the Caliper team about this right when 6 came out, actually. So I'm just listing some things here. they actually have some information on their website that kind of goes into all the details, but the horizontal curve detection and the merge weave behaviors, so those are things that have changed in 6 that should kind of be improving. And something we noticed when we were looking at the parameter analysis was that the default values for standstill distance changes between 5 and 6, and it seemed like it got a little bit more conservative from what I recall, which actually more closely matches the recommended ranges that we have in the guidance document. So if you're using version 5, just know that 6 that stuff is changed. There's maybe some other things, but and then just integration with HCS, and then the additional driver behaviors, and there's a automated vehicles one, which is something that Tom mentioned. I guess fully rolling out maybe in the next version, the next build of 6. But
And Adam, one thing that I guess I've noticed as well is just general runtimes. So depending on the size of the model, I think TransModeler 6 has some enhancements to quickly and efficiently run some larger networks compared to maybe previous versions as well. Tom might correct me if I'm wrong, but that was my experience for different models. So
That's correct, Jacob. In fact, we've a lot of research into improving runtimes, and if you have a TransModeler, will take advantage of as many cores that are on your processor as available. So we're constantly looking to improve the runtimes, and this has an impact, especially when you get into the larger area models, especially if you're doing something like dynamic traffic assignment over a regional model. And just one quick thing, some people may be wondering the difference between TransModeler SE and the full TransModeler, and I always like to say that TransModeler SE, great, there's the comparison. The big thing is, two big things: about 85% of the functionality of the full TransModeler at a fraction of the cost. The network size is limited to 100 links and 20 nodes, which is still a pretty good arterial study if you think about it that way. And in fact, Ohio DOT has standardized on the use of TransModeler SE to do simulation work in the state of Ohio. So there's at least one agency, in fact, North Carolina as well. But on SE particular, ODOT has said that it's sufficient for doing most of the simulation work in that state. So it's still, even though people think of it as a lighter version, it's still pretty robust.
Yeah, so thanks, Tom. Yeah, you keep helping me with these transitions, but yeah, so I wanted to point that out, that there's an SE version, that there's a more in-depth comparison table. I just took a kind of screen grab here, but you can see that it does contain most of the features. Tom's saying about 85%. There are some kind of more, I don't know, premium or detailed features that you can see that aren't in here, but it does have most of the basic stuff that you would need, and at a much lower cost, and as long as your network is small enough, it can probably handle it. So really, from the standpoint of analysis, I think that TransModeler and TransModeler SE, if you're doing the more basic or typical analysis, can do the same things. It is just kind of as you create a larger model or a more specified model that you're going to need the full version. But there's SE for 5 and there's an SE for 6, I believe. So there's a chance that you have a version on your computer already, or you've been using it, and it might be good to see if you have SE or the full, or if you have 5 or 6, depending on what it is. So yeah, I just wanted to spend a few minutes just kind of talking about the versions and what benefits there might be. If you were in the session yesterday, I kind of spent a lot of time in the VISM versions, but it is just kind of important to talk about what version you're using for the project. I don't think in the guidance we do kind of recommend to use updated versions of the software, just because that's going to be the latest and greatest thing that they are putting out, and so that's the recommendation. But it's not necessarily required that for every project you're using the most current, not only version, but build within that version. So it's just important to note what you're using and understand the differences. And then something that Jake and I were talking about is the difference in build versions, and something that kind of was mentioned about 6.1 coming out. It's good to also understand the differences within the builds, because as you're working on a project, there could be kind of a minor build update that you might want to research as to what changed there. That goes for, I guess, any software you're using, but it could be impacting the actual model that you're working on. While the version doesn't change, the internal build does. And so just, again, things to consider, not necessarily rules you have to follow, but.
Right. And Adam, yeah, just an example of that. Models we've worked on before, there might be continual build updates that are a lot more advanced or further along than the original build that a model we were working on was. But when we reached out to Caliper, and Dan Morgan helped us out, he kind of detailed that a lot of those build updates were on pieces of the software that we weren't necessarily using in our model. So it was something to do with like toll lanes or hot lanes that was as part of those new builds of those softwares, and they have a detailed list of bullets that you could always ask for. Hey, I'm looking to update from build 8210 to 8270. Kind of what are the changes that have been incorporated? And sometimes it's important that you would need to update it, but sometimes it's not necessarily important at that time. Just make sure that you are aware of what updates have been or have happened since you originally downloaded the software.
Okay, so that's probably enough about the versions. We're going to kind of get into a little bit of the coding best practices and kind of walking through the model a little bit. So Jake, do you want to kind of talk through the demo and maybe open things up?
I think we'll just leave it on this slide for now. I don't necessarily have an ODME example pulled up in TransModeler, but there's a ton of different ways that you can develop a demand set. And since TransModeler kind of came after TransCAD, TransCAD, if anyone is familiar, I hope you are on the call, it's OD based, right, from Centroids. That travel demand model kind of OD table is incorporated into TransModeler pretty well. One additional piece to that is you can load vehicles from nodes as well instead of just Centroids, but you can also load vehicles from a combination of the two. So typically in larger models where you have a lot of different alternatives, you don't necessarily want to look at volumes from a node-based demand set. So you could code turning movements on specific nodes and have TransModeler route it through a network based on turning distribution, depending on how you look at it. But if you were to look at a new alternative and not have a demand set developed from an OD perspective, you can get into some trouble because that data that was maybe coded at that specific node is now no longer there because maybe you changed the intersection type or interchange type, and that data is now gone. So typically when we're developing these models in TransModeler, we go with an origin destination demand set. And here's just an example of some data that we've used throughout the country to kind of develop that set. There is an integrated origin destination matrix estimation set in TransModeler. And for example, you could take streetlight gates. No one's familiar with streetlight. It uses LBS data or location-based service data, cell phones from your apps on your cell phones to kind of track where you're coming from and where you're going to. But when you get that data, it's in an indice. It's not necessarily a specific volume. So you can take those relative percentages of where people are coming from and going to as your OD, we call it a seed matrix. You can combine that with Maya-vision counts or agency counts or any ground truth traffic data that you have that's coded onto your TransModeler network and run ODME. This process is pretty streamlined in TransModeler because it's also, you can also be use it in TransCAD as well. We've used this effectively on large networks as well as small networks to kind of get the specific demand sets that we want for our analysis. I think you might have some screenshots of what the interface looks like, Adam, or is that later on in the presentation?
Yeah. Do you mean just these general kind of turning tables?
Oh, I actually can pull it up quick if we have time,
Sure.
if you don't mind.
Yeah.
Let me share my screen. So everyone should see an intersection. Let me pull up the demand set quick. So I created just a quick example for this project with a simple demand set for an intersection kind of in the southeast of is it Lexington? Sorry,
Yes,
I live in Omaha, so I don't want to mess up any naming of any cities. So in TransModeler, under the demand set, under OD matrices, there's an OD matrix estimation toolbar. And then you have a ton of different options that you can use to kind of test different delay function, or not necessarily delay functions, but test different input methods or different options such as bounding down your matrices. So kind of one lessons learned or best practice when you're running ODME, if you're running it on a large network, is you definitely want to bound down your seed matrix. So you don't want to give ODME, regardless of using TransModeler or any software or doing the calculations yourself, 100% free range to kind of change any OD to match your counts. So kind of best practice is to give it a bound. So say you have 10 trips in your seed matrix from this O to this D. You could bound it to say it can only grow 50% or decrease 50%. So it can go between 5 and 15. That way that you get a better demand set that keeps your trip lengths in relation to what your seed matrix is as well. But this is just a good tool to play around with when you do have a larger network. And it can also be used pretty effectively on smaller networks as well. I can give you back your screen if you want, Adam.
Sure. So this is really like, I guess when I'm thinking about it, if I'm doing a study, I have likely collected or been given traffic forecast or intersection counts or ramp and freeway counts or a combination of the two. So I just have that data, and while they might be balanced or they work together, they're not representative of origin destination, which is something that we've talked about in the other sessions a bit, but that kind of gives the kind of insight to where people are coming from and going to, like we've been mentioning. And so in this way, you're able to kind of, with some built-in tools in TransModeler, blend those things together to get a more kind of refined look at your volumes. So it's kind of mixing both worlds, the magnitudes of your actual turning movement counts, trying to honor that as much as it can with where it knows the kind of the desire lines are from start to finish. So
yeah, and I guess for as part of that example where I'm saying street light on the top, that could also be a sub area data set out of a travel demand model as well. So we've used that effectively where you're more or less taking the same selection that you're pulling from a sub area from TransCAD, using that to develop your microsimulation model in TransModeler, but also using that same area and those O's and D's that come out of that sub area as your seed matrix for ODME. Because obviously there is an upfront cost for Streetlight if you were to use it. That sometimes if you have an available tool like a well-calibrated travel demand model or well-validated, that it can be just as useful as using different probe type data.
Okay, so I'm going to kind of keep rolling here, but yeah, this was just a discussion about vehicle demand and how to get a matrix maybe from count data or from segment data, so that you can be working with OD matrices as in terms of your inputs, instead of just location counts or things to do with individual vehicle routes. So this is kind of transitioning to the route discussion. So in TransModeler, TransModeler creates all of the routes in the network for you. So you don't have to specify, that somebody needs to go right here through the next two intersections and then turn left. TransModeler will just identify based on the network what the possible routes are between all the combinations. So it's using the physical network and then kind of those origin and destination points to establish those routes. And I guess something that's maybe worth pointing out is that just by default in the software, there are 3 different route choice options. You can find that in your project settings. So it's definitely worth investigating and worth kind of looking into based on what kind of project you're working on. If you're not using dynamic traffic assignment, or I guess really even if you are using it, it's worth knowing what are the assumptions being made about vehicle routing. And so this is maybe a little bit of an in the weeds conversation, but just kind of looking at the help information and trying to come up with a quick kind of 1-sentence summary for each one of these. Deterministic shortest path is they are listening to whatever you select here. So travel time, delay, distance, I think is an option. They're going to listen to that, and the vehicles are going to pick the absolute shortest path between origin and destination. So even if that's maybe not the most logical route, that's what they are going to choose. And then the stochastic shortest path is similar. They're going to pick a shortest path, but the cost associated with each of those paths is random. So maybe that's more similar to real world conditions. And then probabilistic shortest path is kind of running a multinomial logic model about, those aren't words I normally would use, but remembered reading it, to simulate essentially a driver's choice amongst a set of alternative paths. So it can look at kind of the travel times and try to establish a little bit of, even though this is not always the way that someone would get from origin to destination, it is a viable way, and so it will assign vehicles to that. And so it's assigning vehicles as they enter the network, and each of these 3 kind of route choice methods. And so that's kind of the route choice options that are available to you. If you're just running a normal traffic study or normal traffic analysis. We've talked a few times about dynamic traffic assignment, and that's kind of a deeper dive into doing this, into routing vehicles. But I think it's important to mention, just because of the features that are available in TransModeler and the pitfalls, but B, the usefulness of dynamic traffic assignment. Again, zooming out at a high level, dynamic traffic assignment is kind of the way that anybody probably drives in the real world. You're taking into consideration a lot of input factors when you're trying to decide how you're going to get to work or get home, or get to the sporting event and find parking or whatever it is. So you're thinking about this road versus that road, the delay you're seeing ahead of you versus what might be there on another road. It's kind of what you're thinking is happening with Google and Waze data. And so it's kind of built into this TransModeler software, and in my mind, it's kind of based on that underlying routing methodology. So you're not assigning all the routes physically. It's already populating all the routes between the origins and destinations. So it knows what's available. And then by running DTA, you can kind of dynamically change what routes are being chosen in your actual simulation model based on the congestion, the travel time, and general attractiveness of alternative routes. And so when you initially run DTA, this is in the simulations toolbar under simulation options. You can, normally you're in simulation mode, but you can kind of come in here and highlight dynamic traffic assignment. And there are all of these detailed parameters to kind of run through. And so I just kind of want to iterate this bottom statement that this is an iterative process. You likely are not going to get it exactly right on the first try. Dynamic traffic assignment is more detailed, more time consuming, more effort involved, but it can produce more reasonable results. It sometimes makes it harder to calibrate because the volumes are changing and they're moving around a bit as you would expect them to if travel time and congestion indicate that. So yeah, this is the kind of general ins and outs of the process. You're going to kind of come in here and select this and run it through maybe the first time and let it run a number of iterations depending on the size of your model, and it will output some historical turning movement travel times and turning delays, and you can reload that back into your project settings. And then when you run your model, this is what your model will use to select its travel path. So you have to first run DTA with a bunch of iterations, kind of as we're showing here. This is kind of up to 50 iterations as it's trying to kind of converge to a consensus, and then generate those travel times. And then when you rerun your model, you're going to pull in that data and try to rerun it and see how that impacts it. And so you might be going back and forth running it again. And so again, we kind of grab this flow chart off of the help menu in the TransModeler help, but this kind of walks through the fact that it is iterative, and this is maybe the flow of what you're going to need to do. So you can see we're kind of starting out here, and then we run kind of the first iteration. We have everything set up. We run the first one. We then kind of get the travel times, and then we are kind of checking how that's performing, calculating the convergence, and then potentially looping back through and running it again. So just if you're working on a project where DTA is relevant, or you think that there are multiple paths that people will take between origin destination and will be impacted by travel time, that would be a useful thing to analyze. I guess I'll use this example again today. The first TransModeler project that I personally worked on was a downtown grid network roadway closure project. And so that was the kind of future scenario. We had the existing scenario, which was just everything's open, typical roadway network. And then they were talking about closing a block for several months and then opening it again with maybe 1 or 2 lanes instead of the full 4 or 5 lanes. And so we're running those different scenarios, and so dynamic assignment and using that historic travel time data helped with rerouting people through the network in logical ways. So in Kentucky, there are not always use cases for doing this. If you're looking at a corridor project, intersection project, a set of intersections, there's likely not alternative routes. You don't need to worry about all of this, all these ins and outs. But if you're looking at a larger network or a project where it's very clear that if you're just logically thinking about how you would drive it as a person in the real world, there are multiple ways in which you could do that. Then maybe DTA is the path to go down. But should be something that you're kind of establishing in the scoping of the project, because it will impact the data you need and the time it takes to do it, which will ultimately impact the results and the kind of the project budget.
And Adam, I guess
Adam,
just to
while
wrap
you're,
up. Oh,
Oh,
go ahead,
Go ahead,
Rob.
Jake.
All right. The pieces that we've really used DTA are those large models where you have a significant amount of arterial network that might parallel a freeway corridor, or you're looking at maybe one-way to two-way conversions through like a downtown system. But also we've used it a lot for different construction staging and signal timings. Say you have a large freeway or interstate project and you need to close one interchange or one ramp. Where is that traffic going to kind of reroute to? So it's trying to more or less use our simulation model that's well calibrated and validated to kind of essentially do what Google or Waze would do and reroute traffic to kind of the next fastest route and spread it out over the network so that you're able to kind of see the impacts of a specific closure or maybe a construction scenario.
And I was just gonna, Adam, while you're pulling up the Mentimeter question, I think you're headed to.
yep.
Tom put in the chat that Caliper's developing a DTA dynamic traffic assignment primer in the near future. So if you didn't catch all of that, and there's other information, more information available.
Okay. Yeah. Thanks.
And I'll say we can circle back to this topic too towards the end. We make sure we get through all the material, but we can definitely circle back towards the end. But I see one person says they have questions. I would encourage you type your question in the chat. You can type it privately to me or to Adam or Jake, whoever you think you want to send it to, or you can just type it in for everybody, or just unmute and ask.
And at the end, we'll have some time to just have general questions as well. So if you wanted to be anonymous, there should be a Mentimeter slide at the end as well. So, okay, so yeah, let's kind of keep moving and try to get through some of the kind of other best practices. Jake, do you want to kind of walk through the intersection setup?
For sure. Make sure I'm doing the correct screen. So you should be seeing about that same intersection with a few little changes to that. I think the first thing, sorry, looks like I'm looking above everybody, but I'm really just looking at my screens above my laptop. The first thing I think we'll probably walk through is just kind of how to load in those parameters. Adam, if that works for you, is just
okay.
So I'm going to go through maybe just creating a new simulation project and just kind of how that would work. I apologize if someone's done this 100 times in the past, but I'll do it relatively quickly. Let's just say we're going to use a new simulation database. Traffic drives on the right. I'm going to hit OK, and I'm going to have to type in an address to kind of get us where we want to be. So let me just type in one that I pulled up on Google Maps. Um, 40509. And let's just use OpenStreetMaps for now, and we'll hit finish. So it'll pull us up to that kind of Costco location that I was talking about in kind of the southeast portion of Lexington. It's going to prompt me to create a simulation database or a DVD. So let me just navigate to where I'm going to save that. Let's just call it model setup. And I'm just going to do training. Hit save. So the first thing you'll see is you kind of have a background of whatever you need for your network. So we could also change this background to maybe a satellite imagery if we wanted to really dive in and look at specific turn lanes, which is typically what you want to do. Obviously, since it's loading in Google imagery, it doesn't refresh as fast. So once you kind of get everything set, sometimes I hide that off the back so that you don't necessarily need to see it. So the first thing we're going to do is go under our project settings, and we're going to load in the parameter file. So all the work that Adam and kind of our whole team has done developing some specific parameter sets for this area. We're going to load that into our project settings. And if you saw some of the screenshots that Adam was using, it says parameters on the top, and it doesn't show that when you load up a new project. So you want to show optional project settings. So I'm just going to click on all of them. We only need the parameters one, but I wanted to kind of show that there's also kind of a transit and then another options. So I already have this parameter file saved on my computer. So I'm just going to go in there and I'm going to load these parameters for KYTC, hit OK, and hit OK. What I was doing there is I'm setting up a project setting specific to this simulation. You also could do it from a global standpoint. So anytime you ever open TransModeler, it'll default to your global settings being the ones developed for KYTC. That would work for maybe agency people at KYTC, but if it's a consultant that might work on projects throughout the country, it's probably a good practice to just load it into your project settings so that it's just specific to this simulation that we're developing. The next thing that we did, there was a lot of work done developing speed profiles for different roadway types and different roadway speeds. So urban versus rural arterials, urban versus rural freeways and interstates. So the next thing I'm going to do is import those functional class lookup tables, or no, sorry, road class definitions. So I'm going to go import there. And I'm going to click on that. And then once I've done that, I'm going to save this quick as a simulation project, .cmp. And if I go into our road classes and I go to, let's just go edit road class, you now see these arterial and freeway road classes that we've specifically developed for KYTC, and the desired speed distribution from that drone footage that Adam has probably mentioned previously in other discussions is loaded directly into here. So I'm just going to click OK for now. Save it again. I get in the habit of doing that with any software I use, whether it's Excel or anything. So just a quick example of kind of the interface. I pulled up the road editor. Just want to look at maybe adding an intersection quick. So I want to, actually what I'm going to do is I'm going to close this one and open up one that I've already kind of started developing that we wanted to look at. So this is kind of the end product of what we were going to get at, looking at these kind of turn lanes and everything. But I'm going to go into the road editor and just delete this out for a second and then kind of draw it back in just so everyone can kind of see. So we have a 4-lane arterial kind of on the northwest southeast and a 2-lane arterial kind of in the northeast southwest. So I'm going to just quickly add these. Let's just say they're 35-mile-an-hour arterials. Be easy enough. And then you can change the number of lanes as well. So I'm going to add a 4-lane section here. You can see that that doesn't have a median. So I'm going to add that on both sides. And if I were to dive in a little bit closer, I can spread this intersection out so that it kind of aligns with what is there. So here's kind of a quick example. Oops, missed the green for accept. So here's kind of an example of without those turn lanes, what that intersection might look like. What Adam had talked about before, under map, there are a number of layers you can mess with. So one thing I'm going to show is I'm going to change the lane connector color to something a little bit brighter so that we can kind of see and make sure that we're providing the right lane connectors through the intersection where vehicles will kind of track during a simulation. So I'm going to show those as a bright green. And now I'm going to show how you would maybe add some turn lanes. I know that this is a little rough, but I don't want to kind of bore anyone with the details because this is something you can kind of do on your own as well. There's a number of different things in this road editor, but one thing we're going to do is add a turn lane. So that's on this top right. And one other thing I'm going to do is in the settings under options, I'm going to change these links to transparent while we're drawing on them. That way we can kind of see what we're doing. So I'm going to add this turn lane from this link, or this lane to this lane. Actually might be easier for you to see not with the transparent segment. So I'm actually going to turn that off for a second.
Adam, one of the things that we did is allow you to change the color so that you could get a better contrast
For
for
the
those
transparency?
transparent settings. Yeah, that
Yep.
was a complaint that I had, and we just said, hey, we need to, because sometimes you get a really good aerial, a really good satellite, and the pavement is light colored. Sometimes it's dark. And so it gives you the opportunity to choose a color that'll give you the best contrast if you want to go with the transparent feature.
Yeah, that's a good point. So here's a really quick, rough kind of sketch of that intersection with the appropriate turn lanes. One thing to note, obviously in a best practice scenario, we would kind of modify these turn lanes so that they're kind of to the full extent of what they exist in the field. But for this example, we just more or less kind of wanted to show how we would draw those in. The next thing, I'm going to actually close the road editor. I'm going to open up the signal timing window, and I'm going to actually add a signal at this location. So we're going to, all I did was click on the info button. I want to call it a traffic actuated signal. Let's say northbound is our main approach because it's the 4-lane. We go into these phases. So TransModeler will automatically kind of take its best guess at what type of phasing is at this intersection. So if I were to click through phases 1 through 8, it's assuming protected lefts on all approaches. And if I went into the ring barrier diagram, it's just going to kind of take a quick shot at, let's use an 80-second cycle length and see what happens. So there's a ton of signal optimization that we could show you, but in the essence of time, we're just kind of leave it at this one for now. One thing I am going to do as well is just show you that it's a little bit hard to see maybe on your screen, but mine's probably a little bigger, that there's different shading types for right turn on red and for permitted or protected lefts. So a protected left will be a solid green. A permitted left will be more of a hatched green, kind of like I showed there. But I'm going to click it one more time, hit save and close. And now this is not a time that you would probably start running a simulation, but might as well just kind of show you how that would work. I've already created an OD table, which is kind of why I kept these outer nodes before. So all I'm going to do is just hit play. And I'm going to let it queue up for a little bit. But that's just kind of a quick example of if you have your demand set already, you can quickly and easily kind of develop an intersection with rough signal timings kind of in a matter of minutes. I don't know if it took me 3 to 5 minutes to kind of develop that from scratch, but that's kind of one of the beauties of TransModeler is you can quickly and easily kind of develop these different type of alternatives without doing any kind of heavy model coding. One other thing I wanted to note is the integration with kind of any GIS or kind of Esri based or Google Earth type imagery. So this is an example I did just saying, let's say there's a project X off this site, or we had a line file from a design file for an alternative. All I did was I saved this KMZ and I literally just dropped it in and it shows up in TransModeler, and I can change the color based on your layers. So this is my project X. I can change the line width, I can change the hatching, what have you. So you can do a lot of things and put different pieces into your file so that it can kind of add that value to the visualization aspect when you're running an alternative or a specific simulation. It looked like Tom had a comment. Rob, were you able to catch that? Or did he send it directly to me?
I sent it directly to you.
Okay.
But
Yeah,
just one quick, and I'm sorry, I don't mean to keep interrupting. You showed the where you brought in the image. There's also a traffic impact study tool that you can actually do a traffic impact study using IT trip generation rates and everything. So as if you were doing a TIA for, using the simulation as the basis of that, you can do it all within TransModeler.
Yeah, good point. Adam, I don't know what the next piece or the next slide was. Did we want to kind of show kind of how you do an alternatives analysis of a different intersection type, or?
So, sure, I had a couple of things I wanted to kind of point out, and you might have mentioned this, but just to kind of show again, so that when you're drawing an intersection or when you're creating an intersection, it shows kind of pretty quickly. You can see that it's detecting that everything is connected, and the ways that it's showing there, and the green connectors are showing that it understands, like, okay, this is a left turn lane, it's going into these other lanes. So you're not, you can edit those connectors if you have you don't want a left turn to go into a particular lane, or if you, the through lanes don't exactly, one actually drops and it's just a right turn only. This is a way that you can help kind of like make sure your connections are correct. It's going to assume some connections, which are typically, if you've drawn your intersection correctly, they're probably pretty accurate. But it's just something to note that the TransModeler is making those assumptions about the intersection connections and kind of the routing choices through the network. So you can see that those green arrows are connecting even on the segments as the lanes kind of merge in or merge out. There are those kind of green connectors present there, and that's just from adding lanes. It automatically goes ahead and assumes, like, if you're in that left lane, you're going to be the one that can get into the left turn lane, and so on. So, but yeah, I think the next step would be kind of demonstrating how you can kind of change the intersection control type, again, without extensive kind of geometric coding or reworking what's going on with the geometry or other features.
Yeah. So I'm going to take, as a caveat, I just created a random demand set at this intersection location before this call. So it has nothing to do with any projects or anything that's going on. It was more or less just a local example of a place that people might know about. So I'm going to now kind of show how you could maybe quickly test, well, what if instead of a signalized intersection, we wanted to maybe look at a roundabout at this location. So I'm going to use the same demand set that we were using before, and I'm actually, similar to what I did before, I'm going to delete out this intersection just to kind of show, for an example, what we would do. So let me go and select my road class of 35 mile an hour arterial. Let me reconnect these two roadways. Let me add that median quick. You guys already saw me do this once, so let me try to do it as fast as I can. Let's actually keep these pretty tight together. Bring these back, and we'll start with that. So in TransModeler, we'll talk about this when we talk about merge and diverge scenarios off of an interstate system or a freeway system with some access control. There are some quote unquote easy buttons for different intersection types or different things where you might need to code it specifically in Vism, but it's kind of based off some general assumptions in TransModeler, similar to the lane connectors. It takes its best guess at what you're trying to code. So for this example, let's just say, let's add a roundabout at this location. So I'm just going to select the middle of the roadway. Let's just say it's going to be 200 inscribed diameter, 2 lanes, 16 foot, everything else is fine, and hit OK. So I'm just going to save this quick. So TransModeler automatically created all these different yield points and different attributes of a roundabout. There's always a little cleanup. So this actually isn't a full 2-lane roundabout. So we would probably remove these and add some specific lane connectors so that everything is kind of the typical way someone would drive through a roundabout. So one other thing that I'd probably add is lane connectors here. Doesn't like, and that segment might be a little too short. So let me widen it a little bit. And I'm doing this as pretty much fast as I can. So it's not going to be perfect for this example, but so
even
right
going
there,
as fast as you can, if it took me 4 times as long, it would have taken me 10 minutes. So, you know what I mean? We're not talking about a matter of hours to test different scenarios. It's something that you could feasibly do pretty easily.
right. So I'm going to use that same demand set, and I'm going to kind of queue up a simulation, let it kind of get to a point, and I'm going to slow it down, bring it back open. So here is what, with that demand set that I had developed, what a roundabout would potentially look like from a simulation perspective at this location. Some things I've kind of breezed over a little bit, and we'll probably talk about them later in the discussion, but I think probably now would be a good spot for this, Adam, is if I went back into my project settings and went to my input. So right now I just have a demand set for 4 nodes, the entry nodes and exit nodes of a typical intersection. If I go into the options for this and look at the setup, I'm just simulating a 3 to 4 p.m. time. I just picked a random time, but my time distribution is constant over time. So that would say if I put 100 vehicles in, it's going to spread those 100 vehicles equally throughout an hour, and there's going to be no peaking. So that's one thing that when reviewing specific models, that's one thing that sometimes gets missed. And I don't know if Adam, if I kind of sound like a broken record, if you might have mentioned that during the last couple demos of other software. But if I go to curve-based, I can actually
keep mentioning it, Jake. It's good to mention it.
Yep. One thing to kind of note, you can more or less set your peaking characteristics globally, but you can also, instead of doing it globally, you can actually take an hour matrix and do some matrix manipulation to develop different peak hour characteristics, maybe throughout a larger model. So I'm pretty used to working with larger OD data sets from TransCAD, so I don't necessarily use the curve based every time, but this is just an option. So let's just say it actually really only peaks for 15 minutes. It's got a crazy high or crazy low peak hour factor. I'm going to rescale this so that we get to 100%. So now we're going to say that 40% of the demand actually occurs during 15 minutes. So I'm going to click OK, and I'm going to run that simulation again, and we're going to actually go to 5:15 and look at how much extra demand is occurring. So as you saw before, there wasn't any congestion on this approach node from the southwest. Now, since we're showing 40% of that demand with essentially a very low peak hour factor, say everyone's trying to leave Costco at the same time, that would show up as the congestion at this location. So just a little kind of nugget about the demand set on how it's very important to apply some sort of peak hour factor or kind of demand curve when you're running a simulation.
So I got a question in the chat. Can you use 15-minute data instead of manipulating hourly data?
Yes, you can. I don't have one queued up, but in the project settings, let me see if I can do this on the fly. I don't know if I can, but let's go to this matrix for a second and say that this matrix that I developed that has 1,850 vehicles in the entire thing, let's say that's really a 15-minute demand set, and it's not an hourly demand set. So in that matrix, let me go to contents, add matrix. So let's say it was really, that first matrix that I showed was really just a 15-minute. So in this one, let me see if there's an easy way to copy. Sometime I'm doing this in Excel and then I bring it over like most people, but that's the other thing. Some things are pretty intuitive. Let's just say each 15-minute was the same for this example. I could then go into the project. Let me close this. I could go into the project settings, go into my input, my demand example, and now the contents are 4 different matrices. So I could select all of these, and I would have to set specific time classes. Usually I don't do them all in the same matrix. I usually do 4 separate matrices if I need to. But yes, the short answer is yes, you can do it. We can chat after this demo to kind of show that.
And you can do it by vehicle class if you want it. If you knew
Yes.
that trucks behave differently, you could set that up in such a way. So you have a matrix for trucks and a matrix for cars, and you could also have that throughout. But
Yeah, and while you were giving me that time, if you select the time dependent matrices as your time distribution, see how the start time drops in there. And it kind of already assumed that since I had an hour before, it's going to break it into 15 minutes. And like Adam said, you could also maybe add on an hourly truck. You can kind of mix and match and say, oh, trucks don't peak like vehicles do. So let's put an hourly truck matrix, apply a vehicle class to that specific OD table so that we don't have trucks following the same kind of peak hour factor that maybe commuter vehicles would.
All right, another question in the chat. Volume data can be entered via OD matrix or turning movement counts at each location. My understanding is that these are mutually exclusive options to enter volumes. We can't mix and match, right?
That is, Tom, correct me if I'm wrong, that is correct. The mix and match aspect would probably be best served through ODME, origin destination matrix estimation, like we discussed before. One thing to always caution when you're just using turning movements, I did load one in just as an example. So this was more or less me hand coding the same turning movements that would essentially create that OD table. I could set a peak hour factor for the flow field, and I could create more flow fields of AM, PM, midday, Saturday, what have you, and click OK. But that turning movement table is all tied to that specific node. So if I went into my nodes and displayed them.
I think it's actually tied to the links, Jacob.
It is tied to the links.
Yeah.
But at the same time, if those links get broken in any sense, your turning movement table does not correlate. So if we were to change that to a roundabout, those volumes would not effectively get brought through the network correctly. And that's why that's the beauty of using an OD table and kind of setting your externals or even internal nodes, so that you never really have to touch those in your simulation, and all that OD that's generated through the calibration and validation at the beginning of your project with your existing model is used.
The question asked by Vina, I don't know the exact answer. I don't think it's good practice to have both an OD matrix and turning movements. I think you should use one or the other. You could try it. You could try to. It allows you to show those as an input, so you could try to have both. But I don't think it's really good practice to mix and match, especially because you run the risk of double counting or something like that. Maybe the example is you are doing some type of traffic analysis and you add a development that maybe has, it's a distribution center and you want to do trucks in an OD matrix, but your background traffic is based on turning movements. I need to find the answer to that question. I'm sorry, I don't know it right offhand, but I just think it's good practice I really think it's good practice to do an OD matrix whenever you can develop one, because then your application of that becomes a lot broader. But we've made it where it's very simple to enter intersection turning movement counts as well. Plus, an OD matrix will allow you to quantify the actual demand. If you're over capacity and you have a count at an intersection, then basically you're just counting the saturation flow rate and not the demand. So you would actually not capture the demand as an input to the simulation.
And Tom, we've kind of worked around that in different aspects by, if you have a set number of turning movements through a corridor, say you have 5 intersections, you could plug those turning movements in, have a simulation run, and maybe pick a longer simulation period than just the hour that the demand set is. You can then export a path flow table, is what it's called, from the output settings, which kind of gives you these origin IDs, destination IDs, and what the total volume is through that simulation. So if you make it a more unsaturated condition and let it use distribution percentages to kind of route that volume through the network, you can then kind of take that kind of CSV or that bin file and develop a matrix from that that you can plug back in, so that when you do change or look at a different alternative, you're not necessarily breaking your network, so that those ODs can kind of stay on the outside and not be messed with.
Good.
So I guess as trying to wrap up the answer to the question, maybe is it's a little unclear maybe if you can use both, but the recommendation would probably be to transition turning movement count data into an OD matrix when you can, and I think there are a couple ways you can do that. If you have or don't have streetlight or travel demand model data to create an ODME easily, you can start to do it this way that Jake is mentioning, running the simulation through, getting these kind of origin destination pairs, and then creating a matrix from that. So if your network is really small, maybe that's not a worthwhile exercise, but if you have definitely multiple routes or multiple paths, or you're going to be editing those intersections and you might lose some of that data as you make those edits, it's probably worth it to try to spend the time to create an OD matrix. But
I just saw a chat come in about saving different alternative types for analysis. Might have been a direct chat to myself. I don't have my chat window open. I guess I could have done that.
yeah, so the question was about doing alternatives analysis. What's the best practice to save files of alternatives to switch back and forth? So let's say you're looking at it like what we were just talking about, the signalized intersection versus a roundabout. Is it so you can retain all the information between the two files? Kind of what's the best way to do that?
The best way that we found for our practices, and I guess it can probably vary depending on who's necessarily working on it. There are tools under File, Archive, where you can archive specific scenarios or archive projects. And all that really does is take everything that you're working on, throw it into a zip file that you can then throw on your server as either a backup before you do a specific thing, or as a specific alternative that you want to save and then pull open and work on separately. So typically what we do is archive these projects, then we actually restore these archives, rename the simulation project, not necessarily rename everything in the file itself, and then we can use that as the alternatives analysis. And I was going to kind of show what maybe a little bit of a workflow would look like for that.
So you're saying it's going to continue to reference all the same turning movement tables and delay tables, input matrices, but
Yep.
you're just within the root folder, you're probably just saving different .smp files.
Right. So here's a project that we're currently working on for Ohio DOT. So under each folder, we have a different alternative, and these are all developed by a colleague of mine, and then all of them were archived onto our server, and then I restored them onto my machine locally so that I could run them efficiently. That's the one piece where if you're kind of using a server to maybe run DTA, and it's potentially a network license, a lot of times, I'm sure many of us have gone through the struggle of it doesn't run as fast as you would like it. So sometimes best practice is to run it locally on your machine, off the network, and then load your results back onto it as you're saving and keeping that record of kind of your steps along to develop your simulation model.
Okay. Yeah, Tom just mentioned in the chat that going to File, Copy to create a new project is also an option. For the sake of time, I guess, Jake, do you want to quickly just jump into kind of the freeway merge diverge for 5 or 10 minutes, and then we can jump back to the slideshow?
Yes. So here's an interchange off of I-75, just west of that intersection that we were looking at before. I'm actually, like I did 100 times before, just kind of delete out what this is and just kind of show how we would develop a kind of freeway merge scenario. So one thing to do when you're developing a model from scratch, you always want to, you don't have to, but you can typically select the road class that you want to draw if you already know that. And if you don't know it, you can always set it as undefined and then go back through selection sets later on in the project and set that before you run your simulation. But let's just say it's a 65-mile-an-hour freeway. I want to add a link. I want to make it a one-way link, and I want to make it 3 lanes. So since traffic drives on the right, it kind of models the left edge of pavement. So I'm going to click and then double click to stop. So that's my 3-lane segment. And then I want to also add a ramp. And I want to add a 1-lane ramp from this on-ramp. And if you click in the interim, it will kind of use these points to curve the ramp to match the geometry. And then when you see that kind of bigger square, that's where it's connecting with the roadway and creating a new node. So if I were to zoom into that location, right now there is no acceleration length for that ramp once it gets onto the interstate. So what we're going to actually do is there's a couple ways to do this, but I'm just going to do a quick way is I'm just actually going to split this link where the acceleration lane ends, and I'm going to add a lane off to the right. I'm going to save. So one thing that is done is now there's an acceleration lane, a 4th lane for those vehicles to get up to speed. Now, if you sat in on the training yesterday, which unfortunately I was not able to due to a different project, but Vissim kind of treats it a little bit differently than TransModeler does. Like I said before, with that roundabout easy button, similar type thing. If I were to look in the lanes layer and I were going to info and select this outside lane that's highlighted in blue, and we were to pull up that info, it under the dropped scenario, see how this is coded as yes. This is where TransModeler knows that a ramp is coming into contact with a freeway link and knows that it's coming in on the right, and it goes back to 3 freeway lanes downstream of this node or of this merge segment. So without having to remove this lane connector on the kind of north side here, vehicles will know to merge out of that acceleration lane into the kind of general purpose lanes before they continue on their way. Now, one thing I kind of want to caveat with that is depending on the area of the country or even the city that you're working in, sometimes the kind of drivers can obviously behave at these merge conditions a little bit different depending on the location. So there are options to change the lane connectivity, is what it's called in TransModeler, to a number less than 1 to maybe convince people to get out of that lane either quicker or not in kind of these high congestion scenarios. So for an example of that, say this I-75 was queued up and it was almost stop and go traffic. Depending on the city you're in, some people might stop at this entrance score and wait for a gap to get into the traffic stream, or vehicles might go all the way into this acceleration lane and then merge over. So depending on what you see from video or just general observations along the corridor, you can specifically change those lane connector properties so that you're able to match that type of behavior in your simulation model.
Okay, yeah, this is highlighting some of the processes here of kind of the simplistic way that you can create these merge conditions, and TransModeler is able to pick up on, based on what the geometry is, what's going on with that lane, and that it's going to drop, and that it will have kind of a different behavior is kind of important to understand and helpful in kind of network coding and simulation. So, okay, I can kind of jump back into the presentation. We covered a lot of the actual software walkthrough, and hopefully that was helpful. I know that, again, we were kind of mentioning this won't be a kind of all-in-all course, but maybe a crash course in setting things up and getting things coded and kind of more common issues or areas that people are working with. So intersections and merges and weaves and diverges are generally the trickier things to look at, and making sure that you understand what's going on. And so I had a Mentimeter question. I can pull it up really quick. I think it was just a question about kind of a check-in point, but we can find the right window.
Jake, while he's looking for that, was there a separate chat question that just went to you, or was it the one that was in the to everyone?
I think it was the one that went to everyone. It just sometimes WebEx doesn't do the great job of showing those chat ones when you're displaying your screen. I know you can open it up on the side, so I did that, so I was able to look at it now, and it was to everyone.
Okay.
So in general, it's just, check in about model coding. I'm going to keep going here. There was a question, and there's also a maybe, but as we're going, if you have questions, or once we get to the end, I want to leave some time so that we can talk about more questions. So I'll kind of roll through here a bit. So we talked a little bit about the parameters throughout these sessions, but and Jake kind of showed how to pull them in, but I'll kind of do another overview, also for the sake of rewatchability and people using this. But we looked at 9 different parameters in this project, and we used Kentucky data to analyze them. And again, this is kind of a snapshot of those 9 things, and some of the results graphs that we came up with. But in general, we're looking at how do the defaults in TransModeler and Envisim respond to Kentucky behaviors, and how do we make things more apples to apples and more applicable both between softwares and to Kentucky. So we want this to be kind of a completely agnostic process, but we want the results to be comparable, and we want them to make sense. So we developed some recommended ranges for both sets of software where it makes sense, and left certain things alone where we felt like the defaults were kind of checking out to be similar to what Kentucky data was showing. So this is all documented in the guidance document in detail for both pieces of software. So they're separate data values, tables, graphs, etc. The analysis process was really the same, but making sure it translates equally between the software was important. So then we kind of walked through this a bit, but the actually importing the parameters, it's a little bit different than what I was showing yesterday in Vissim. It is similar to the read additionally, I guess. You're importing it into an existing project. Because of the way that some of the data is stored, it's really best to do this in 2 stages. So importing the parameters and then importing those road class definitions. The parameters help define things that the road class definitions are referencing. So you kind of can't have one before the other. So we already were walking through this previously, but I just thought it would be worth sharing here. That's kind of the basic process there. And I had another Mentimeter, mostly just about talking about more on the parameters. We can spend a few minutes if people have specific questions about a parameter. There were a few yesterday, and so feel free to weigh in on that, and I might just pick top 1 or 2 that we're talking about as it relates to TransModeler and as it's important. So,
and Adam, as those are coming in, I think one important thing to note is that all the parameters that we were looking at were specific to kind of the things that we could measure in the field. Now there's a ton of different parameters when it comes to DTA and other things in the model that, depending on your specific scenario, you may need to maybe adjust. Maybe there might be a connectivity bias between freeway and non-freeway links, whether or not people are more willing to take the freeway versus stay on an arterial. Those types of things you can't necessarily measure in the field and are used in DTA and might need to be adjusted, but aren't included kind of in those 9 parameters.
Sure. Yeah. And I guess that also kind of goes to the locality of projects. So certainly with any of the parameters that we are recommending, and I'm positive it says this a few times in the manual, if you have local data that kind of overrides what the defaults are saying, or you think that is more valuable, certainly kind of bring that up in project scoping or before you get to calibration to mention that, because that's more useful than what we're developing. Probably we're trying to develop information for statewide use and general use. We're not trying to force it on every project. So having local speed data or vehicle composition data or lane change distance information, if you know these ramps or certain interchanges behave differently, that's an important feature to code into a model. Okay, so I'll just talk about maybe these 3 here, different votes than yesterday, but the vehicle fleet composition, at a high level, we looked at the VIN data from Kentucky, and we talked about this a little bit yesterday too, but VIN data for Kentucky, and kind of generated a vehicle fleet based on that. The TransModeler fleet is really not that different from a default standpoint than the Kentucky fleet, but the mix is really between kind of SUVs and middle performance passenger cars. So size is probably different and the behavior is a little bit different. So that mix up is a little different there. And I mentioned this, I think, yesterday, and I'm hoping I still have it open. The Microsimulation kind of summary findings, little cheat sheet. This kind of shows all of the parameter values for Vissim and TransModeler, and then this vehicle classification tab is meant to be interactive. So so this kind of allows, you know, in Vissim you're loading in these specific car types, and in TransModeler they are broken down by what types of vehicles they are. And so again, you can kind of come in here and manipulate these values, and it will update kind of what your percentages should be in ratio to each other in your model based on kind of the Kentucky data. And one thing, I guess two things to point out here. One being that the initial study we revised after realizing, you know, truck data is a huge piece, and we're basing this off of VIN data. So not necessarily, you know, trucks are traveling interstate often. They are not always staying in the state that they're registered, obviously. So we wanted to up that truck percentage, and we almost, you know, just made it a customizable entry field here between cars and heavy vehicles. And Jay is pointing out in the chat that so KYTC have the VIN data. We were looking at the state, but you could narrow it down to county level. And so if you had a project that you felt was different, or you wanted to investigate that, that's something that you could certainly look at in the scoping of a project, or even look at kind of collecting a vehicle classification count. And then we have some kind of images in the guidance document about the breakdown of where the different vehicle classes kind of break into. So let's say you had higher vehicle classes in certain areas, like what does that actually translate into in terms of passenger cars and pickups and heavy vehicles. So the other thing that we point out here is that there, by default, there are some motorcycles in the vehicle fleet, and we've kind of zeroed them out just for the analysis, the purpose of the analysis. Not that there aren't motorcycles on the road, but we're typically not trying to just make a visual representation. We're trying to look at actual traffic performance, and doing it with just vehicles kind of better indicates what's going on there. And there's also some settings with regard to lane splitting that you need to make sure are set correctly in TransModeler if you're going to have motorcycles in your model. So the other two things quickly here are the truck weight to power ratio in TransModeler. We actually, this wasn't a local parameter, but we looked at kind of research data and talking with Caliper. All of the truck weight to power ratios that they have in their models are based on the same research we were using. So we're not recommending any changes there in TransModeler. There are some changes in the Vissim models based on the way that they are doing that. They're kind of applying weights and powers randomly, and there are caps, and so it does affect it. But and then lane change distancing, again, this, I think we might have mentioned this before, but the TransModeler defaults are by a distribution between freeways and arterials, and we felt that they were pretty accurate, pretty good from a just general starting point, conservative sense. And so we're again not recommending any changes there, but certainly on a local basis, if something makes sense to change, you should do that in the model.
And Adam, I guess one point on the critical distance. The one thing that sometimes gets changed depending on the type of alternative that you have is the look ahead distance. So that's kind of how far downstream does a vehicle know kind of what turns they're going to make. So say you have an alternative where it's not typically straightforward, where it's maybe has to take a lot of quick lefts and rights and lefts in order to get through that. Depending on how many nodes it goes through, you might need to adjust those look ahead distances so that people can kind of orient themselves the way they would in a lane. If you have a lot of local commuter traffic that knows they need to be in the right lane to turn into a specific lane to get onto the freeway, just something to look at. If you see kind of vehicles cutting each other off when in the field, maybe people kind of just keep to their own space in a specific lane to get from point A to point B.
Okay, yeah, that's a good thing to point out for kind of making sure your lane utilizations and your kind of weird interactions are set up correctly. Um, so I'll try to wrap up here quickly so we have time for questions, but just wanted to kind of talk about some troubleshooting issues. We've talked about some of this already. I think we've maybe talked about everything on this list to some degree, but the motorcycles being in the models, again, nothing against them, but we're just trying to make sure that the behavior is correct. And if you don't kind of pay attention or have the lane splitting toggled on or off, or the motorcycle volume turned up too high, it could kind of impact your model as they're smaller or they're not taking up space in the queue. The other thing about ODME, so we mentioned this in the beginning about the ODME process and a little bit about doing some restriction on the matrices themselves. So if you're not doing that and you're not like kind of bounding the ODME process, you can often end up with volumes that are not realistic, and then you're kind of into a situation where you're trying to calibrate something and you can't figure out what's going on, and you're manually maybe editing the volumes more than you would like or more than you feel realistic. So making sure to pay attention when you're doing that. And it's really a volume discussion in general. So the next thing being the volume peaking. Jake showed this in the model itself, and there's a couple ways you can do it, but making sure that there is volume peaking really does change the overall outputs. And I know that everyone's probably tired of me talking about that, but it's the basis of it's the base starting point of what you're doing. So it's just good to make sure that that's kind of correct and that you're starting off on the right foot before you get halfway through calibrating a model or setting up a model or testing future scenarios somehow, and you realize like, oh yeah, all the volumes coming in together. So, and then the last thing, just we're talking about the lane coding and the kind of turn channelization or turning at intersections, just making sure that that's coded correctly and that things are being captured at an intersection and that the right connectors are linking together. When we were doing the roundabout example, even though it was very quick to change from a traditional intersection to a roundabout, there were still some small edits that we wanted to make just to make sure the movements are right. So the last kind of thing I had here was results and documentation. So if everybody's familiar with TransModeler, we've kind of opened these project settings a few times, but project settings menu really controls almost everything in your model, the setup, the inputs, and then it also controls the outputs. It's also where you pull in the parameters, I guess, but the outputs here, you can select what you want before you run your simulation, and then you're also selecting the increment or the steps and where it's applicable. So if you're just trying to collect certain pieces of information on certain roadways, so you might have a lot of dummy links to feed your network maybe that you're not concerned about, and you don't want to deal with that at the end, or you want to try to speed up the simulation process. You can see down here at the bottom, it's kind of giving you a gauge of speed. for simulation time. So if you want to speed that up, you can toggle around with the selection and the incremental steps in seconds, but it has some defaults in there already. And then, if you don't care about the time, you might make it more granular. And then kind of when you're on the output, you're running it through the output manager. And I just ran one actually earlier this morning, so I could pull this up and show you. But this is where you're able to control what your outputs are going to be, and then you can even kind of narrow that down. So if you collected it for your whole analysis, but you don't want really to know the stats of the seeding period, you can then kind of specify what's going on here and get your outputs that you need, and those can be exported, and you can view them right in TransModeler, or you can export them to a table kind of file, so you can further manipulate them in Excel. But
And Adam, one thing about that, I guess,
yeah,
one thing to note when you're initiating a simulation, the one thing that TransModeler might do is like give you a warning if you are reporting queuing at intersections. It might prompt you to create a super link, which is more or less just chaining a number of links together so that you're able to collect queuing data, maybe that's a little bit longer than a intersection from one node to another node. So there are some built-in kind of checks as you are going into a simulation that you do want to kind of clean up some of those warning messages if you are exporting something like queuing at an intersection, or even some intersection level of service and delays.
yeah, that's a good point. So when you have a situation where the queue might spill beyond the next intersection, creating super links will actually record the full piece of information.
Mm-hmm.
but
From the
you don't need to
intersection
do
you're
that.
concerned with.
So, yeah, not just from where it queued through. So, okay, so that was really most of the content I had here. I just wanted to shout out some kind of free resources if you're trying to learn TransModeler. And Tom, you can feel free to jump in here if you want, but we were looking at the ODOT manual that I believe Caliper helped Ohio develop, and there's a bunch of great resources that they have, YouTube videos and kind of presentations and materials for training that are available. While this is a Kentucky project, Ohio is not too far to the north, so a lot of what they're probably talking about is applicable, and a lot of it would be kind of training up to figuring out how to create models and calibrate models, and kind of the secondary piece that we aren't going through in detail here. And then Caliper also has a kind of a YouTube channel that has a bunch of different YouTube playlists of TransModeler trainings. So I just have kind of included links there. If you come to this at a later stage and you want to look at this presentation, those links are available, and that could kind of help kind of move you forward in the training process. So there's some basic, advanced, and then kind of new features playlist, I think, is what I'm.
And there's also a lot of the screenshots that we took were from the help menu. So if there's any specific thing you're concerned or want some additional details on when you're in the software, you just hit F1 and the help menu will pop up to that specific thing you're hovering over or have highlighted. And also there's a pretty functional search menu in that help menu.
I can just add to that, guys. The ODOT videos that we developed were for TransModeler SE. I mentioned earlier that is what they have standardized on. But other than having a sidebar for some of the popular road editing and signal editing features, the functionality is the same. So those are still very helpful. ODOT has moved those around, and the videos are bundled along with their HCS videos. So there's a list of them that you have to start in somewhere around number 16 or something like that to actually get to the training. We are in the process of developing training videos for full TransModeler that we'll put on our website. We're just not there yet. There are some webinar recordings on the Caliper website. If you go to caliper.com and then in the TransModeler section, there's a webinars and videos tab, recordings of some past webinars, including an introduction to traffic simulation, and then there's a advanced traffic simulation that may be helpful as well. And a lot of this stuff should look familiar, but those are resources that are out there.
Okay. Yes, there are a lot of kind of available resources to bring you up to speed or to help you with kind of refining specific questions. And it sounds like there's going to be more in the future. There's also training probably hosted by them. But yeah, does anyone have any questions at this stage? We have a few minutes here. Sorry we rushed get to that, but I feel like we had a good discussion throughout. So
Yeah, well, we've got just a few minutes left. If you've got a question, you can type it into Menti if you want to, or type it into the chat, or just unmute yourself like Scott.
I just want to say while we wait for questions to come in that I really appreciate, Jacob, your expertise in TransModeler, and to have somebody like Tom Creasy keep us all in line with the product. KYTC has 5 licenses of TransModeler. We are in a better position to be able to consume any work that's done in TransModeler for a KYTC project. So we encourage you all to, I'm going to be, for one, downloading this video and playing it at about 1/4 speed so that I can keep up with what was going over. A lot of great information here. I liked what you said, Adam, about how, there's no replacement for project-specific data. And in our businesses, if you've got to do something quick and dirty, you'll use global values. We hope that these defaults that have been developed by HDR will get you closer to a reasonable answer than you would without any other inputs. Again, I appreciate everybody's attention in this. To have 35 people participating is phenomenal. I'm excited for you. And thanks again for everybody's attention.
Thank you, Scott. And yeah, thank you all. If we don't see any questions, I think we, just say have a great afternoon, and we'll send out emails. Scott, we need to talk with you about getting this up online next week. So this week, all right.
Yeah, Tom's already asked for a copy of the guidance, and we are tickled to death to be able to share it with him. So yeah, get us a final copy, and I'll be getting my crew together to get it taken care of.
Perfect. Thank you.
Okay.
Thank you all.
Sounds good. Thanks, everybody.
Everyone.